Hello everyone. So today we are going to be doing a recorded video just on urban climate, pollution, and traffic. And while those may not seem like they're necessarily connected, we'll be talking about the ways in which they're connected and the ways in which they're different within urban areas as opposed to other areas. All right, so starting off first with microclimates or climate in general. Uh, in urban areas, climate is affected in difference to the areas just outside the city by a couple different factors. So the first one is the structure of the air above the urban area. So urban areas are places of more massive amounts of industrialization. And so that includes more pollution. Also contributing to that is the fact that there's more cars. And so more CO2 is going into the air. And so what happens with that is that there's a greater concentration of not only dust, but also of particles that absorb moisture and absorb more CO2. And this can, include higher proportions of noxious fumes that exist as well. Now, the other factor within this is the structure of the urban surface as well, because a lot of buildings are made of things like glass and steel, and other materials that are a little bit more either heat retaining or heat reflecting. And so these include things with lower albedo, which are darker surface of buildings that absorb more heat. And so that heat tends to stay in these areas to larger degrees. And so urban areas become areas that are hotter than areas that are even just like 5 or 10 miles away from them. And in addition to those heat retaining materials, you have structure of the urban surface that includes rougher surfaces with a greater variety of perpendicular slopes. And this can, face different aspects and cause that reflection of sunlight to, occur. And just going back to one of the terms that we have here, albedo, this indicates how well a surface reflects solar energy. And so when you have low albedo, you are going to have a surface that reflects less and absorbs more. So in terms of radiation and sunshine, there is a greater scattering of shorter wave radiation. So that radiation that's coming directly from the sun, the sunlight, but you have a lot more that's been reflected off of surfaces of the earth, like we talked about on the last slide. And so areas with taller buildings have more shadings because there are taller buildings that are taking off a lot of that shortwave radiation. But you have areas with possibly more long wave radiation. Now, in terms of clouds and fog, you do have higher incidence because of the amount of CO2 that's being absorbed in the air, because of the amount of haze from like either pollution or also because of the different makeup of how heat is being absorbed. You have the chance for different weather systems that end up coming in. And so there's a higher incidence of thicker cloud cover in summer and radiation fogs or smogs in winter due to the increased convection, so the way that heat sort of travels through these systems, as well as air pollution. And you also have a greater concentration of hygroscopic particles. So these are substances that readily attract water from its surroundings through either absorption or adsorption. And this can lead to a faster onset of condensation and therefore more precipitation as well. And so all of this leads to, because of these particles in the air, because of the absorption of heat, day temperatures that are on average 1 degree warmer compared to areas outside of the city. And that may not seem like much, but when we're considering how that might slightly affect weather systems over time, that can be quite a large difference. So looking at temperatures, even during like winter nights, which we would normally think of as much colder, these tend to be 1.5 degrees warmer during winter nights because of that stronger heat energy retention and then also a release that might happen. Uh, and so this can include, at times, even significant temperature increases. So on average, yeah, it's 1 degree difference, but sometimes it could be as much as a 7 degree difference between like downtown area of a city and the suburbs that are just outside of that city. Um, and this is especially true in spring when you might have these big contrasts between what's going on in the city. And all of this can not only affect temperature, but also, weather patterns, like I said. Now, looking at pressure and winds, there is a severe gusting that ends up happening oftentimes because you have this wind that is hitting these buildings, and how the wind sort of travels around these buildings can, sort of build up and cause these like sort of wind tunnels in these condensed areas of land where, the wind is forced into a smaller area and therefore the impact of it is even greater. And so this can also cause not only, wind changes and, it to feel, at times colder, even though it's not actually colder, but you could have, cause strong local pressure gradients to be wildly different, especially from windward to leeward walls. So those walls that are not facing the wind. And then you also have these deep, narrow streets, especially in areas where you have like skyscrapers, uh, and these are much calmer unless these prevailing winds sort of funnel them, like I said, into these wind tunnels. Now, the other effect that can happen is not only just like the impact on like weather, but also like, the impact on sound as well. And this can also cause a lot of reverberation and sort of an echo effect. And so it may make it hard to locate the sound source of noises. And this is especially, important when we're thinking about like crime, right? If someone shoots a gun somewhere in the city, if it causes that echo effect, it can sometimes be hard to sort of figure out where that is coming from. And so for police officers and other personnel, it can become something that's quite important to sort of quickly locate so you can protect people. So in looking at humidity, you also have a decrease in relative humidity due to the lack of available moisture, as well as the higher temperatures. And so, these high temperatures, therefore, because of this difference, may be countered by very cold but stable conditions. When we're looking at sort of how these climate changes are different in cities. Now, in terms of precipitation, like we said, there is a greater absorption that is taking place. And so if there's greater absorption of particles in the air, of moisture over time, you may have very intense storms that may end up occurring. So, and this is especially true during hot summer evenings and nights. And this can lead to greater instability. So you may have a massive downpour in the downtown area, but it's much smaller on in the suburbs because of the difference in terms of how much either air pollution is going on or that structure of building surfaces. And then there is a probable higher chance of thunder as well that ends up occurring in different locations as well. Cities also see less snowfall and also briefer times in which it is cloudy as well during those winter months. Now, all of this leads us into a principle that's pretty important to know, and that is the idea of the urban heat island. And so everything we've been talking about leads to this principle that urban areas are oftentimes generally warmer than those of the surrounding countryside. And so if we're thinking about an island, that's, a place where you have like sort of stable conditions outside of it, or it's different outside of it, and then all of a sudden you have these massive changes that could occur. And so this urban heat island effect can, take place in which you have average degree temperatures that are 2 to 4 degrees warmer, especially in the most downtown areas. So, earlier in the slide deck, I talked about how there was a 1 degree difference. That's across the entire city. So, the downtown area could be even more steep when we're thinking about, 2 to 4 degrees warmer, because that is, such a concentrated area of so much activity within the city. So in looking at the urban heat island effect, there is a difference between urban and rural areas. And this is greatest under calm and high pressure situations. Like I said on the last slide, heat is greatest usually at city center and sort of plateaus across the suburbs. So it's fairly consistent across the suburbs before the heat drops even more in the rural areas. So those rural areas are going to be the coolest out of that entire area. Suburbs go up a level, and then, going into the city, you have gradually warmer temperatures until you reach downtown. And like I said, this is caused by a number of different factors. So one is that heat produced by human activity, like driving cars, or just the amount of people, our natural body heat, or doing work, construction work, those sorts of things. You also have changes in energy balance, that buildings have a high thermal capacity to hold in heat compared to rural agricultural land. You also have the effect of airflow. So turbulence of air may be affected by some of these buildings that exist here. And then you have a reduced number of open water bodies as well. So even if you have a river, you may have it very built up right around the river. And that's going to be different than if you go out to a rural area where there's generally like less building around that river. The composition of the atmosphere, you also have smog and smoke and haze trapping heat. Reduction in thermal energy that's required by evaporation. You also have a reduction of heat diffusion that's going on, and then a pollution dome. And so these particles that are coming off of this pollution sort of creates a dome that traps in a lot of heat compared to other things. Now, all of this leads us into sort of talking about air pollution to a certain extent. Because, one of the main causes of this climate change, or this, sorry, wrong terminology there, but of this sort of climate difference that's going on in cities, is the fact that there's poor air quality. And poor air quality affects about half of the world's urban population. And this is quite important because several 100,000 people die each year because of the poor air quality, especially when, exposed to it over time. And so as urban growth increases, the problem is going to continue to increase, not only in terms of the climate stuff that we just talked about, but also in terms of the amount of people who may be exposed to it and who may suffer ill health effects, including death. And so one of the things that we need to keep in mind is that oftentimes this is, this effect is most extreme in low-income countries. So those cities that are developing and where you have very rapid growth because of the patterns of development according to the DTM model. And so these cities also have fewer resources to be able to cope, such as having money for technologies that might sort of cap pollution in the air, that may have built up public transportation systems, which would allow more people to not drive cars, or less people to drive cars. And so, all of this, has an important effect. But another thing you may not have thought about was that, oftentimes the cooking differences within the house are different. So people in low-income countries are probably more likely to have a wood-burning stove inside to be used for cooking and heating. And so you have this smoke that is, filtering through the house that's not just being caused by things going on outside, but rather, you're around smoke all the time. That's not necessarily great for your lungs. And so all of those factors, cause a difference for low-income countries in terms of the, development, in terms of the types of pollution that is going on there. Now, one of the major sources of pollution is motor vehicles. So low-income countries, newly industrializing countries, these are 10% of the world's motor vehicles. However, as these places begin to or continue to develop, you're going to see expanding car usage. And unfortunately, a lot of these cars are less fuel efficient and less pollution efficient, I guess, than other types of vehicles in more highly industrialized countries or high income countries, because that is what people can afford. This may be their first car ever. And so, thinking about that as well. And so because city planners as well have to balance people's needs for housing and education and healthcare and employment, oftentimes environmental concerns rarely get put on the top of the list because, it's a more long-term issue where you might not necessarily feel the effects of pollution, your first months in a city, but you're certainly going to be feeling it over years and decades. And so unfortunately, it oftentimes gets put to the bottom of the list as a city begins to develop. Now, in terms of reducing emissions, there are a couple things that we can do to make sure that we're using less emissions. So first is to burn less fossil fuel. Use more energy efficient technologies like hybrid or electric cars. We can also use public transportation rather than private cars. So private cars meaning like our own cars. Using carpooling schemes where you're sharing rides with people. Cycling or walking more. Also for some of the lesser technologically savvy cars in some of these low-income countries or in high-income countries, using catalytic converters that would reduce emissions, and then also increasing enforcement of emission standards. And that last one especially is built on government policy though, and governments making sure that they're doing the right thing to protect the environment. Now, another thing that might help, whether it be with climate or with, pollution, are building up greater areas for urban trees and green spaces. And these are really vital to the health of the city and of its people, not only for mental health, but also for physical health as well. So it does help reduce the effects of the urban heat island because trees soak up CO2, and so that's less CO2 that is being put into the air and is less CO2 that is absorbing those heat trapping materials. It also helps to reduce noise levels. Sound does not bounce off of trees in the same way that it would a building. And so it can help to absorb some of that noise. And then it also helps to filter and clean the air as well. And so if you have things like a very healthy urban forest where you have a lot of trees in a city, air quality can be drastically improved. That it can help to lower the air temperature, like we said. It can help to, if you have lower temperatures, this can lead to lower energy use, like having, if it's not as hot, you're not going to put on the air conditioner as high as you would have. And so that's going to save energy. There's also other things like living roofs where people plant plants and even trees on top of a roof, and this can lead to even greater cooling because that sunlight is being blocked from being absorbed when it's coming into the city to a greater degree because trees have higher albedo than blacktop does or than a building does. And so this can lead to a greater amount of protection for the city. Unfortunately, though, we have a lot of depletion of urban green spaces, and this is especially true within developing countries where their focus is more on growth in that given moment and not necessarily about preserving urban, green spaces, because they want to get as many people into the city as possible, or as many, a ton of people are moving into the city and maybe using some of those urban forest spaces for, housing and things like that. But you also have, differences in terms of if we just look at like the amount of space that someone has in London. So if we look at the size of London, each person has about 50 meters of squared space based on the population and everything else. Whereas a place like Mumbai, which is rapidly growing as well, and has been rapidly growing, has less than 2 meters squared. And that can really have an impact on people's mental well-being as well as that physical well-being, like we said. And so, sometimes cities have made this a premium to sort of create these open areas. So if we think about like Central Park in New York City, that is a massive urban park right in the middle of Manhattan. And it would have been easy for New York City to sort of say, okay, we're going to, create a smaller park, but it's, quite useful to have this massive park in the middle of the city to protect the well-being of its residents. So all of this is important for those reasons. Now, the last thing I just want to quickly talk about before you guys read about it more in your chapter excerpt is traffic, because this is one solution to sort of shortening or reducing pollution, as well as some of the other things we've talked about here. So urban traffic congestion does vary with days of the week. It can vary with time of day. It can vary with weather. It can vary with the seasons. But it affects people's livelihoods as much as anything else that we've talked about today. And traffic is often more congested during the following times. So weekdays between 7 and 9 a.m. and 5 to 7 p.m. That's why we did our IA data in the way that we did. Monday mornings, Friday evenings, both of those are more heavily trafficked times. Friday evenings, especially because people are leaving town. I'm sure you may notice that there's a lot of traffic on like Friday evenings and Sunday afternoons because people have gone out of town for the weekend and are heading back into the city. And then the start of the school year, festivals, national holidays, all sort of build up that traffic as well. And during summer vacations, urban congestion is less. Okay, I'm sure your parents notice during the summer when there's less school buses, less people driving their kids to school, that there's less traffic. And so all of those things can sort of not only impact, livelihoods, but also if you think about it, like if it takes you an hour to get to work instead of a half hour, because of traffic, that's more fuel that is being used and more pollution that is going into the air. And so finding some of these other strategies for lessening traffic, it can become incredibly important to protecting the environment. All right, well, if you have any questions, please let me know. But for now, please go ahead forward and read the 2 chapter excerpts so that you can move forward on today's notes. All right, thank you. Bye.